This is Mrs. Often, and in this final video of the video series on special segments and points within triangles, we have working on the coordinate plane with special segments and points. So we're going to start out by finding the circumcenter of triangle GOH with vertices located at G, 0, -9, O is at the origin, and H is at the point 8, 0. Let's begin by graphing this triangle. Here it is. And our next step, because this is the circumcenter, I'm immediately going to think of perpendicular bisectors. Now, I also am going to recall that the circumcenter of a right triangle, which this is because GO and GH are perpendicular to each other, forming a right angle, that circumcenter is going to lie on the hypotenuse. So that's going to help me with a check on whether I did this correctly. So step one is graph the triangle. And there's my equations for the two perpendicular bisectors. So my first one is here at y equals -4.5. And my second one is here at x equals 4. Now, that is going to really be enough for me to find my perpendicular bisector, to find my circumcenter, but I am going to graph the perpendicular bisector of my other triangle, of my other side anyway. I'll do that in navy, and it is going to land right here at 4, -4.5. And while this had a slope of +9/8, this is going to be my perpendicular slope. There it is, and you can see it intersects at the same point. So they intersect at the point 4, -4.5. That is the circumcenter of GOH. Worth thinking about, if you haven't already, why it's okay to only graph 2 lines to determine the circumcenter. And is it also okay to just graph 2 lines to determine the other special centers of triangles? So think about that as we work through these problems. Here's another example, finding the centroid. So here my triangular region is located at 6, 6, 10, 7, and 8, 2, and these are going to be labeled with some variable names for their points in just a minute. We want to know at what coordinates will the triangular region balance. So when you see that triangular region balancing, that is the centroid. So here's my diagram. And we want the midpoint of AB and N be the midpoint of AC. So I'm going to put M right at the midpoint from 6, 6 to 10, 7. That's going to go right here. Switching to pen mode. And that's going to be a vertical line with the equation x equals 8. That's helpful because it's going to tell me the x coordinate of my centroid right off the bat. If I find the midpoint of AC, it's going from 6, 6 to 8, 2. That center is located at, or that midpoint is located at 7, 4. And that line has a slope of 1. Equation is y equals x minus 3. Now I can solve this system to determine the coordinates of the centroid simply by substituting 8 in place of x into my second equation. And I can see right away through visual inspection that this point of intersection is at 8, 5. Again, I only need those 2 linear equations that I can solve to find the coordinates of the centroid. that is going to, again, represent the place where the triangular region will balance. So there's my midpoint formulas to calculate. Now, we also could have done this with using the equation of AL, and that line would go over here. And it would again intersect at 8, 5. My poorly drawn lines. So it would not change the location of the centroid. Now here's an interesting question. Find the average of the x coordinates and the average of the y coordinates of the vertices of PQR and make a conjecture about the centroid of the triangle. Well, we'll notice that the average of the x coordinates, 0 plus 3 plus 6, is 9. Dividing that by 3, it's going to have 3 for our x coordinate. And our y coordinates, 8, 4, and 0. That equals 12. Our y coordinate is going to be at 4. So if we determine the location of the centroid here, here's one median drawn, and here is another median drawn. You can see that they do intersect at 3, 4 for the centroid. So an interesting property of the centroid, you can find it by averaging the x and the y coordinates. Okay, next up we're going to find the orthocenter of triangle XYZ. Now this is determined by finding the altitudes of the triangle and finding their point of intersection. So one thing that I notice right here is that this looks like it's going to be a right triangle. So I do just want to verify that it is a right triangle. That could save me some time in determining the orthocenter, because I know that the orthocenter of a right triangle lies on the vertex of the right angle. So I'm just going to calculate the slopes of YZ and of XZ and compare them. So my slope for YZ is 6 minus 1 for 3 minus 7. That's 5 over negative 4. And my slope for XZ is negative 2 minus 6. Sorry, miscalculated there. Negative 2 minus 1. Over 3 minus 7. So sadly, this is at 3, 4. I was hopeful, but it doesn't seem like it's working out that way. So I am going to have to construct these, and we'll go through that process of finding the orthocenter. Okay, so finding the orthocenter, we're going to start by finding an equation of the line containing the altitude from z to xy. Now the equation of that line is y equals 1. Xy was a vertical line, so the altitude was horizontal. There it is. And we're going to find at least one other altitude. Honestly, we just need to find one other altitude. We've found the easiest one, so then we can kind of pick. Okay, the slope of a line perpendicular to xz is negative 4/3. This line does need to pass through the other vertex. So we're going to just go through that process for point slope form. Fortunately, it's going to clean up nice here. There is our equation. Now, our equation, as you recall, we had y equals 1. So we already know that is going to be the y coordinate for our orthocenter. To find our other coordinate, our x coordinate, we're going to substitute 1 in place of x, -4/3, x plus 10 equals 1. So -9 equals -4/3 x. And through substitution, we'll get our value here. That's going to be 27/4. Or as a decimal should be 6.75. And there's the coordinates of our orthocenter. Okay, so go ahead on your own. Please draw the triangle on graph paper and determine the coordinates of each point. And hopefully you got 0, 2 for the centroid and -2, 2/3 for the orthocenter. I hope you found this video helpful in understanding how to use the orthocenter, centroid, incenter, and circumcenter with triangles graphed in the coordinate plane. Thanks. Have a great day.